Hi all, welcome to Graphics Desk.
In this video, we'll talk about problem related to projection of solids. And the problem statement is a hexagonal pyramid, side of base 40 mm and axis 80 mm is resting on HP on its edge of its base such that its apex is 60 mm above HP. Draw its projection when the axis of the top view is making 45 degrees to VP. This is a problem has appeared in the Mumbai University examination in May 2025. So let's begin. So first of all, you need a very long horizontal line as XY. Let's draw that. Now, why do we need a long line is because there will be three different sections will be coming, three different diagrams of front view and top view would be coming on this line. So we need it very long. Okay, so let's draw the top view of hexagonal pyramid of side 40 and axis length 80. So we'll draw a vertical line here as axis and we'll draw front view and top view. So let's draw a circle of 40 mm and then hexagon in the top view. We have drawn a circle and divided it into 4 different parts. Now we'll mark 6 parts as a hexagonal here. Remember the hexagon is resting on its edge, which means we need to have an edge on the left hand side. Okay, as this is a hexagonal pyramid, we'll have all the sides connected to the apex O. Now let's name the points. This would be the top view of the hexagonal pyramid. Now we'll draw the front view. So we'll take the projections from this on the VP and we'll draw front view. Axis height is given as 80, so we have measured 80 here. So this is our front view of the hexagonal pyramid. Now let's name the same points over here. Now you can see that these 2 points have the same projection, these 2 points have the same projection, these 2 points have the same projection. So these on the XY as the pyramid is resting on HP, all these 6 points would be on the XY line. Now let's read through the second condition. Okay, the second condition says that the apex is 60 mm above the HP, which means this point is above HP. So we'll have to tilt this diagram so that the O point would be 60 mm from XY, and that we'll draw here. Let's draw a 60 mm line at first. Now this is 60 mm from XY, which means point O in front view is supposed to lie on this line. Look at the 2 conditions that I mentioned here. That apex is 60 mm above HP and the pyramid is resting on HP, which means the AF is the edge if we consider, then O point will lie here and AF would remain on the XY line. So let's take the distance of O and O and AF, and we'll draw a line here. Let's say this is our AF point for A and F. Then the distance from this point to the 60-degree line, that means here, would be the point O. Now we have to draw the same pyramid as this, inclined like this along this line. So let's measure the distances using compass. So the distance of point EB, which is same, let's measure that from AF and O as well, which will give us this line. Okay, we got point EB, which is here. Similarly, let's locate point representing CD. Okay. Now to avoid confusion, I'm just rubbing this out so that this is not part of the line. This is simply the 60 mm line parallel to XY. So we don't need this anymore. Okay, so this is how our pyramid look like. Now this is our top view, which is same as this, but meeting the condition of apex being 60 mm from the XY, that is horizontal plane, and resting on the edge. So that's our top view after tiltation. Now let's draw the, this is front view after tiltation. Let's draw the top view. So we'll have to carry the projections. Now projections for E will be on this. Projection of D and F is the same. For O, this is the projection, and this is the projection line. For C and A, for B, this is the projection line. I'll quickly extend these lines. Now to draw the top view after tiltation, let's take the projections of these points from the front view, cutting these projections, horizontal projections. So now the projections are taken, and wherever they are cutting to each other, that's where the point would lie. So for point O, this is the projection, horizontal projection, this is the vertical projection, so this is the point. A and F, so this is A, this is F, E and B, E is this, B, and then C and D, which is this. Now while drawing the top view, there would be certain lines would be dotted because they would be hidden behind the object. So first of all, to avoid confusion, we'll draw the border line of the object, and then we'll see which would be the dotted lines. So let me name these things first. So let's draw the outline. Outline will always be solid. Okay, now the lines that we have to draw here are connecting D to O, C to O, A to O, F to O, E to F, F to A, and B to A. Now, when we are looking in the top view, the closest point to observer are C and D. That means the line going from C to O, D to O and C to O would be a solid line when you are looking in this direction. So let's draw solid line here. The farthest point from the observer when you are looking in the top view, when you are looking in this direction, are A and F. That means these are the farthest point which are on HP itself, which means this is the line, and all lines that are going from these 2 points would be dotted, which means A to O, A to B, A to F would be the dotted line. Similarly, F to E and F to O would be a dotted line. So let's draw that. So this is our front view and this is the top view after meeting the condition of apex being 60 mm above the horizontal plane. Now the other condition that we have is that in the top view the axis is making 45 degrees to VP. That means we have to change the orientation of the same object in such a way that it will be, this axis would be 45 degree to XY plane. Now here the axis is from the center point. This is the axis. So let's draw a line at 45 degree first. We'll take from here. So this is the line at 45 degrees. Now let's locate point O. Let's call this as point O. Now when we are changing the orientation of the object, the distances from XY would naturally vary. So these projections, horizontal projections, would not be useful while drawing this thing, but we'll have to carry these projections horizontally in the front view. So let's locate this as point O, and in a similar way what we have done here, we'll use the distances from this point as a reference and we'll locate rest of the points. So first let's locate this point, which is the axis where it is cutting to the base. Obviously it will lie on the same line. Let's measure the distance in this diagram and we'll take this over here. So this is that point. I've not named it, but this is the point. Let me name O here. Now using these 2 points, we'll be able to locate the rest of the points. So let's do that. So this is where your point E will come. This is point D. If you notice, this geometry is symmetric to axis, so distance from O to E would be the same as O to B, distance from O to D and O to C is same, so as O to A and O to F. So let's look at point F here, and at the same time we'll look at point A as well. So that's our F and A. Now we are left with C and B. Now we have got all the points. Let's name them, and I'll use blue color to name these because these are the final top view objects. Again, the dotted line will remain same, the solid line will remain same. So O we have already got it. So C, this is B, this is E, this is F, E, and E. Let's connect the lines. B to O solid, CB solid, this is solid, this is these solids. Now this is our final top view, and that is why it is in blue. Now let's draw the front view in a similar way. So we'll be carrying the projections from this particular front view over here, and we'll carry the projections vertically from the top view to locate the front view above XY. So let's carry the projections. So these are the projections, vertical projections from all the points. Let's take the horizontal projections. So CD would be at the highest elevation. So now we have got all the projections. Now while marking these points, be careful which projections on which you are marking these points. So let's look at the points. O on this line, so this will be our O. I'm using red pencil because this is our final front view. C and D are lying on this projection. So this is C, so this is our C. D is D. Similar way, let's look at other points. So we have got all the points here. Let's name them. So this is O. Okay, so we have got all the points here. Now, it is very difficult to visualize this object right now, but let's draw the outline first, which will be solid. Okay, the only point that is not connected is point B. Rest of all the points, including O, are on the periphery of the front view. So point B, all the points that are going through point B would be dotted line. I'm sorry, would be solid line, because B point is near to observer when we are talking about front view. So all points going from B would be solid points, solid lines. Now B is connecting to which all points? O, of course, to C and A. That means you have to draw solid line here. Okay, now which are the missing lines which you'll have to draw, and those will be dotted. So as it's a pyramid, all the base points would be connecting to O, which means A to O is solid, B to O is solid, C to O is solid. You have to connect D to O, E to O, F to O, and these three lines will be dotted. Now this is the point at which the axis is cutting to the base, so we draw that. in the center line, line format a center line. So this is our final figure, and the conditions that I mentioned will simply have it here. This is exactly 60 mm. That in the problem mentioned as the apex from the HP. That means in front view you will have the 60 mm and the axis making 45 degrees. To VP. That means in the top view it will be 45 degrees to XY. So this is how our final solution would look like. Thank you for watching this video. We at Graphics Desk committed to spread the knowledge. Be a part of this journey, share this video and spread the knowledge. Until next time, bye.